Hi there, Matt. So for question 7 of the short answer section, this is a probability question that tests the understanding of one property. So here it says two events A and B are such that P are A. So they tell you what the probability of A is. So we know chances of getting A. We also know that the chances of getting B. And we also know this random fact here, probability of the intersection of not A and not B. What they really wanted you to test, or what they wanted to test you here, is mutually exclusive. So what's the property that they're talking about here? For two events to be mutually exclusive, it just simply means that there is no relationship between the two. So for example, if I said A was the chances of me winning the lottery, right? And B was the event of me squatting, right? It'd be weird if I drew a Venn diagram that represented something like this, that the lottery and me squatting, that there is an overlap. That's implying that my squats, somewhere there is a chance of my squat and winning a lottery, so A intersection B, is related. That's why there's a chance of it happening. Otherwise, if my squats is unrelated to the chance of winning a lottery, then what you should expect is that the event A and event B should be separate, and therefore the intersection between the two, the chances of both of them occurring, whether I squat and the winning a lottery, is even going to occur at all, it has to be 0. True? Because, my squat, I'm assuming me squatting all these years, has not won me a lottery at all, but it's just the idea that it's a 0% chance. So the property that they wanted to test here was when they say mutually exclusive, they're testing this. They wanted you to prove that probability of A intersection B is equal to 0. So after saying all of this, when they say show your reasoning, you just needed to prove that mutually exclusive, that you understood mutually exclusive just meant it's when the probability of event A and event B is going to be 0. That's all you needed to show. Okay? And there's a lot of ways to show this. The solutions that I sent to you, they used a specific method. And what they did was they worked out what probability of A intersection B was, and it turned out to be 0.1. And how do they work this one out? Well, they use the addition rule. So they've got the addition rule. They used the addition rule and they figured out, I'll explain this later, but essentially their goal was just to find this. You don't have to use the addition rule. You can use it, or you can use a Venn diagram. I personally normally use a Carnot maps. I find that that's the best way when you get problems involving probability A, probability B, and then especially a random one like this one. I find that it's actually much easier to work with if you drew out the two-way table or a Carnot map and you wrote it out as A dash, and then this is B dash. And we know the total probability has to add up to 1. That's getting everything. And we start filling in the points that we know. So we know the probability of A, all of A is 0.2. So all of A should be down here. This is all the total probability for two regions added together to get 0.2. And then it says probability B is 0.75. So all of B should total up to 0.75. And so that tells me straight away that then if this is the chances of B, well, then this spot here is the chances of not getting B. Now, if you have 75% chance of getting B, well, then you have 25% chance of not getting B. And therefore, all the chances of getting B plus the chances of not getting B should give you the total of 100%. Okay, so it makes sense that it adds up to 1. And you can feel that at this point here as well. That means this is 0.8, the chance of not getting A. And what else did they tell you? They told you a random fact that not A intersects with not B is 0.15. So not A and not B must mean this is 0.15. So if you've got this piece of information now, you can actually fill out all the little missing details. So horizontally to get a total of 0.25, clearly this had to be 0.10 because 10 plus 15 is 25, right? But then if this is 0.10, then vertically, we can already see that this also has to be 0.10 because 0.1 plus 0.1 gives you 0.2. And we can pretty much stop here because all we wanted was, again, find probability of A intersection B. True? And we've got the answer as probability of A intersection B is equal to 0.1. But we know that for them to be mutually exclusive, well then probability of A intersection B must equal 0. But since it doesn't, since probability of A intersection B does not equal 0, therefore not mutually exclusive. Okay, so that's essentially what this question is testing. Now, how you get to probability of A intersection B is equal to 0.1. I like to use Carnot maps. What they did on this other hand is they used the addition rule, and this is how they did it. So you first think of a Venn diagram. Okay, so what they did was they said, okay, well, let's think about it logically. Here's a Venn diagram. Okay, you got A, you got B. Now, the reality is that they gave us this random fact. They told us that the probability of A dash intersection B dash is 0.15. Now, you see, that is this entire region on the outside. This, around the circles, is the area outside of the Venn diagram, and that has a total area of 0.15. Okay, so that's the chance of you getting anything, 15% chance of getting anything outside the circles. So then what they said was, they said, well, that would imply that what I'm going to color in yellow right now, this is all of A union with all of B, because I'm coloring all of A and all of B, right? So this section here in yellow is A union B. But if that's A union B, well, the logic is that A union B plus the blue region, so the yellow plus the blue region should give me everything. True? So what they said was, well, if probability of A union B, which is the yellow, this is the yellow region, plus with probability of A dash intersection B dash, that's the blue region, right? And that's meant to give you everything, which is 100%, which is 1, then you can solve for probability of A union B by simply replacing this as 0.15, because we knew that was 0.15, right? So this one we don't know. Let's call it X. So X plus 0.15 is meant to equal to a total of 1. So what should X be? Logically, you can minus 0.15 on both sides, and X will equal to 1 minus 0.15. Okay, and 1 minus 0.15 is 0.85. And that's what they did there. That's essentially what they did. They just said, all right, well, if I got the total 1, take away the area of A union B, that gives me the area of the outside of the circles, which tells me that A union B must be 0.85. Okay, so now that I know A union B is 0.85, so the yellow region right now is 0.85. They then use the concept of addition rule. Now, you know the addition rule was A union B, probability of A union B is equal to probability of A plus probability of B minus the double up, which is the A intersection B. So that's the addition rule. Okay, so search that up. It should be in your formula sheet. But if you didn't understand that, you could have thought about it on a logical sense. If this is a circle A and this is circle B, right? That's the yellow region. Yeah, so that's what I colored in yellow. That's A union B. Now we know that A union B is meant to equal to 0.85, right? But we also know that all of A was 0.2. And we also know that all of B was, what was it again? 0.75. Okay? You can kind of work it out logically in the sense that if I called this X, Y, and Z, right? You can think of it as X plus Y. Those two regions should give you 0.2. And you can think of it as that Y plus 7, Y plus Z should equal to 0.75. So in a way, you can rearrange this and say y is equal to, bring the x across, 0.2 minus x, and you can substitute, there's a bit of more substitution to actually solve this actually. How else can we do this logically? Oh, that's right, I forgot. We also knew that x plus the y plus the z should total 0.85, right? So x plus y plus z should have gave you 0.85. Notice here, I just realized, notice here y plus z should equal to 0.75. So really you're saying x plus 0.75 should equal to 0.85. And that allows you to kind of figure out what x is, and x is clearly 0.1. So if you know x is 0.1, you can sub this back in, and then therefore y is equal to 0.2 minus 0.1 is equal to 0.1 as well. So therefore this is 0.1, this is 0.1, and this is I think 0.75? Yeah. No. What is that again? 0.7, 0.65. There you go. So that's another way of doing it, but addition rule will be more direct. As you can see, there's a lot of ways to find A intersection B. I personally like to use the Carnot maps. I find that this all the way to year 12, this is probably the most useful. But this is also nice for you to play around and visualize a Venn diagram and start to utilize the tools that you have with a tree diagram to transfer it to a Venn diagram, and then using what you understand about Venn diagram properties. This is a good starting place, but it is more confusing. Okay, so if all of that explanation was a bit too confusing, maybe you just stick with this one. But if you like, maybe spend a bit of time and think about how I was going through this and what did I do to figure out A intersection B, because I've done it in 3 different ways so far. This is their way, using addition rule. That's one way. I used my sort of logic with the X, Y, Z regions, so just the A union B section. That's section number 2. And then I use Carnot maps to get there as well. So there's a lot of ways, but you find the way that you think you're more likely to stay consistent with and accurate with. Okay? I hope that helps.